In this video, we're going to take a look at second-order linear homogeneous recurrence relations, which essentially just means we have a recurrence relation where the next value in the sequence is dependent on two previous values. I actually prefer solving second-order homogeneous recurrence relations as opposed to first order, simply because there is a process in place as opposed to just sort of guessing with iteration or back substitution. Here we're actually going to turn it into a polynomial. So on this slide I did sort of list out the steps for you, but the steps don't really make sense until you actually do it, so I'm not going to spend time talking about the steps. We're just going to jump right in and do these questions together. For our first example, we're going to solve the recurrence relation a sub n is equal to 5 a sub n minus 1 minus 6 a sub n minus 2. Notice this is second order because there are two values needed in order to find the next value, and therefore there are two initial values as well. That's how we know it's a second order. The very first step is we need to write this as a characteristic polynomial. But there are a few steps involved in that. So what I'm going to do first is I'm going to take my initial recurrence relation and I'm going to set it equal to 0, which means I need all of the terms to the same side. So notice I've subtracted 5a sub n minus 1 from each side, and I've added 6a sub n minus 2 to each side so that I have everything equal to 0. So that's the very first step, is to just write everything, get all of the terms on the same side, set it equal to 0. Then we're going to replace any values that are initial terms, and we're going to replace it with r to that same exponent. So a sub n becomes r to the n. 5a sub n minus 1 becomes 5r to the n minus 1. And 6a sub n minus 2 becomes 6r to the n minus 2. Then what we're going to do is we're going to divide everything by the least degree of r to the m. So whatever least degree that is, and that is going to be the n minus 2. So essentially I'm factoring out r to the n minus 2 for each of these values. And that means this is going to become r squared. So just in case you're struggling with that part of it, I always never know how much to review. But if you're thinking about it, I'm kind of dividing r sub n divided by r sub n minus 2. And when I divide, I subtract exponents. So I'm taking r and then n minus 2. So n minus n obviously cancels out the n, but minus 2 gives me r squared. So that's where that came from. So that gives me minus 5r to the first, and then plus 6r to the 0, which of course is just 6. And then we're just going to divide that on each side. So my characteristic polynomial is r squared minus 5r plus 6 is equal to 0. Now, I don't ever need to see this work. I went through that work for you so that you understood where it came from. In the future, you'll notice I'm just going to be looking at whatever this value is, and that's going to be the first term for my highest degree. So now that we have our characteristic polynomial, we just need to solve it. So hopefully you're very familiar with factoring. If not, I will do my best to find some good videos to link in the description of this video. But really I'm looking for factors of 6 that add to negative 5, so that gives me r minus 2 and r minus 3. Negative 2 and negative 3 add to negative 5 and multiply to 6. And then by the zero product property, I'm essentially setting each of these equal to 0 and solving, so that gives me r is positive 2 and r is positive 3. I want you to note that these two values are different. 2 and 3 are not the same number, and they're both real numbers. So we have two real distinct roots, and this is the form that we're going to use for that. So I'm going to rewrite my solution as a, and again, a is just going to be a variable that we're going to solve for coming up in just a moment, as is b. So I'm going to take a, and then I'm going to take my first root to the nth power, and then plus b, and then my second root to the nth power. And no, it doesn't matter if I used 2 here or and 3 here or the other way around, you get the same solution. Now what we want to do is we want to take what we've just come up with right here, and we're going to use our initial conditions. So we're going to use, with n equal to 0, we're going to replace values in this equation with n is equal to 0. So essentially this is a sub 0 is equal to a and then 2 to the 0 plus b 3 to the 0. Well, a sub 0 is an initial condition, and that answer is 1. So that gives me 1. I'm going to actually write this over here. 1 is equal to 2 to the 0 is 1, so that gives me a, 1a. And then 3 to the 0 is 1, so that gives me 1b. And then I'm going to do the same thing for n is equal to 1. So that gives me a sub 1 is equal to a times 2 to the first plus b times 3 to the first, which reduces to 1 is equal to 2a plus 3b. Now I have a system of equations. So again, we've already just reviewed a little bit of factoring, and now we're going to review solving a system of equations. And you can choose substitution or elimination. This is a pretty straightforward one. I'm going to choose substitution. And again, hopefully you're familiar with that, but the basic idea is I'm going to substitute a value for one of the variables into the other equation and solve for the remaining variable. So I'm going to rewrite this first equation as a is equal to 1 minus b, just by subtracting b from each side. And I'm going to plug that into this equation. So this equation is now 1 is equal to 2, and instead of a, I'm substituting 1 minus b, and then plus 3b. So that reduces to 1 is equal to 2 minus 2b plus 3b. We'll subtract 2 from each side. That gives me negative 1. We'll combine negative 2 and positive 3 to get positive b, so b is negative 1. And then how do I find a? Well, I'm just going to take the other equation, either equation really, but I'm going to take the simplest one and say 1 is equal to a plus b, and instead of b, I'm replacing it with negative 1. I'll add positive 1 to each side, which is going to give me 2 is equal to a. So there's a, there's b. So now what? Now I take it right back to here. I'm going to replace a with 2, and I'm going to replace b with negative 1, and then I'm just going to clean it up a little bit. So a sub n is equal, notice this is 2 times 2 to the n, so using those rules for my exponents, 1 plus n is n plus 1, so 2 to the n plus 1. And then negative 1, so I'm just going to turn it into a minus instead, and then 3 to the n. So this is my solution. This is my explicit function that will find any solution for this particular sequence. Now, of course, you might not take my word for it. You might say, I don't believe you. So let's try a practice. We already know a sub 0 is 1 and a of 1 is 1. So let's find a2 and then also try a2 down here. So a2 says, to do a2, we're going to take 5 times a1 minus 6 times a0. Well, a1 is 1, so that's 5 times 1, and a0 is 1, so that's 6 times 1, so 5 minus 6, which is negative 1. So a sub 2 should be negative 1, so let's check it down here. A sub 2 should be 2 to the 2 plus 1 minus 3 to the second, and that's going to give me 2 to the third, which is 8, minus 3 squared, which is 9, which is negative 1. Notice we get the same solution, so I feel pretty good about ourselves. Here's one for you to try on your own, so press pause, try this question, then press play to see how you did. Okay, I'm going to go through this one as quickly as I can to make sure I save room for the next type of question when you have two roots, but they're exactly the same. So I'm going to rewrite this as a sub n minus a sub n minus 1 minus 6a sub n minus 2 is equal to 0 by gathering all the terms to the left side. I'm then going to write this as the characteristic polynomial, so I'm looking at the 2 and saying that's going to be my highest value. R squared minus 1r minus 6 is equal to 0. And then I'm going to factor. Factors of 6 that have a difference of -1 are -3 and +2, which gives me roots of 3 and -2, which of course are distinct real roots. That tells me I'm going to have a sub n is equal to a times 3 to the n plus b times -2 to the n. I'm then going to use my initial values. So I'm going to let n equal 0, and I'm going to say a sub 0 is equal to 3 to the 0, I'm sorry, a times 3 to the 0 plus b times -2 to the 0, which gives me 1 is equal to 1a plus 1b. Then I'm going to do the same for n equal 1, which gives me a sub 1 is equal to a times 3 to the first plus b times -2 to the first, which reduces a sub 1 is 8, so 8 is equal to 3a minus 2b. Now, on our last example, I used substitution, so this time I'm going to use elimination. For elimination, we are simply looking at coefficients in front of either a or b and trying to make the same coefficient but the opposite sign. So I'm going to choose to take this whole equation, oh, I hate that purple color, sorry, this whole equation times 2. So that's going to give me 2 is equal to 2a plus 2b. I'm simply going to rewrite this equation. So this is 8 is equal to 3a minus 2b. And then I'm going to add them together in one big addition problem. So 2 plus 8 is 10. 2a plus 3a is 5a, and b's cancel. That's why it's called elimination. It eliminates one variable. Divide each side by 5. I get 2 is equal to a. And then to find b, I plug it back into either one of the equations. So I'm going to choose 1 is equal to a plus b, and instead of a, I'm replacing it with 2. So that gives me, subtracting 2 on each side, -1 is equal to b. So what is my solution? My solution is a sub n is equal to a is 2, so 2 times 3 to the n. And then b is -1, so I'm just going to write minus, and then -2 to the n. That is my solution. Please be careful that you don't try to do this because that's not going to work, because remember that -2 inside is going to alternate whether you're adding or subtracting. So this is my solution. I'm going to leave the checks to you. Great, let's do another question together, and this one is going to have a little bit of a hiccup, but you'll find that it's going to be very similar. I'm going to start the same way by collecting all terms to one side and then turning that into the characteristic polynomial, which is going to give me, again looking at the 2, r squared minus 6r plus 9 is equal to 0. And I'm going to factor by looking at factors of 9 that add to -6, which are -3 and -3. Multiply to 9, add to -6. So here's where things are going to turn out a little bit different, because I no longer have distinct roots, I now have identical roots. So instead of a sub n is equal to a times 3 to the n plus b times 3 to the n, because two roots are the same, I need to include an n. So it's bn, 3 to the n. Great news is, however, everything else is the same. So what I'm going to do is I'm going to let n equal 0. I'm going to replace a sub 0 a 3 to the 0 plus b times 0 times 3 to the 0. And you'll notice this is going to give me a sub 0 is 1. So 1 is equal to a times 1, so that's a, and then b times 0 times 1, which is 0. So that just gives me 1 is equal to a. So good news, I already have one value. Then I'm going to let n equal 1, so a sub 1 is equal to a times 3 to the first plus b times 1 times 3 to the first. And that's going to give me a sub 1 is 2, so 2 is equal to 3a plus 3b. So I already have a, and I'm just going to basically plug 1 in for a to solve for b. So this is going to give me 2 is equal to 3 times 1, or 3 plus 3b. Subtract 3 from each side, I get negative 1 is equal to 3b. Divide by 3, I get negative 1/3 is equal to b. So you might have a little bit of a heart attack there because now we're dealing with fractions, but notice this is a fraction that is a power of 3, so that is going to come into play in just a moment. So as we did before, I would rewrite this. A is now 1, so really that's just 3 to the n. B is negative 1/3, so I'm going to, instead of plus, I'm going to write minus 1/3, and then n, and then 3 to the n. So you might be tempted to leave your solution like that. Hopefully you are not tempted. Instead of 1/3, I want you to think of 1/3 as being 3 to the negative first. So I'm going to keep this first guy the same for a moment. And this is 3 to the negative first, and then 3 to the n. So I'm just going to add n and negative 1, so that's n 3 to the n minus 1. So I'm adding n and negative 1 together. Lastly, I am going to go ahead and factor out that 3. And in fact, what I'm going to do is I'm going to factor out not 3 to the n, but I'm going to factor out 3 to the n minus 1, which leaves me here with 3, because obviously 3 to the first and 3 to the n minus 1 multiplied would give me 3 to the n, and minus n, because obviously I would be factoring this term out, which would leave me just with the n. So this is my final solution right here. And you're going to find quite often when you have a multiple root like that, that you're going to have to do some of this with the writing fractions as reciprocals in their powers. One last practice. I really tried to keep this one under 20 minutes, but I failed, so sorry about that. Go ahead and try this one on your own and then press play to see how you did. So I'm going to go straight to the characteristic polynomial here. R squared minus 4r plus 4 is equal to 0. Multiples of 4 that add to negative 4 are negative 2 and negative 2, which means I have two roots that are the same and they're both 2. So I'm going to rewrite, or I'm going to write my function as a sub n equals a times 2 to the n plus bn 2 to the n. So same root twice. I'm going to let n equal 0, which is going to give me 1, a sub 0 is 1, is equal to a times 2 to the 0, so that's just a, plus b times 0, so that gives us 0. So that means a is equal to 1, and we have solved for our first variable. Then I'm going to use my second one, so I'm going to let n equal 1. So a sub 1 is 3, and then a times 2 to the first is 2a, and b times 1 times 2 to the first is 2b. So I have 3 is equal to 2a plus 2b. I'm going to then plug in 1 for a. And I get 1 is equal to 2b, so 1/2 is equal to b. And again, if you want to go ahead and write that as 2 to the negative 1 to help you out, that is just fine as well. So what am I going to do? I'm going to take this equation, And I'm going to write a sub n is equal to a, which is 1, so that's 2 to the n, plus b, which is 2 to the negative first, n, 2 to the n. Just as before, I'm going to combine those two together, so I have 2 to the n plus 2 to the n minus 1 times n. I'm going to factor out a 2 to the n minus 1, which gives me 2 plus n. So this is my final solution. So just a scotch over 20 minutes, sorry about that. Up next, we're going to take a look at the general case, which just means what if it's not 2, but instead 3 or 4 or 5 previous terms.